Alright, so we've talked about this theorem before. You should recognize this picture. It's called the radius tangent. Once again, dotted line is my radius. This solid horizontal line is my tangent. And it says here the angle where the tangent and the radius meet will be 90. So that means this angle right here is 90. We've talked about this before. We use this here. When I put a number like 40 degrees, you had to find x. You should take 90 minus 40. That's what we did. But now we're going to use our side lengths because now we're talking about segments instead of angles. Alright, so in this problem here we have our radius, which is 12. Our tangent length right here is 16. That means we have a right angle here. So that means you should remember the Pythagorean theorem. So 12 squared plus 16 squared equals, we'll call it x squared, put an x right here. So, once again, let's just review from last unit. 12 squared plus 16 squared, oops. I'm just plugging it all on my calculator. This comes out to be 400 equals x squared, and then just take the square root of that answer. That means x equals 20. And that's the answer to this side length right here, is 20. Alright, so this is the same concept. Now I got a diameter touching a tangent, so there's still a right angle right here. So now we're going to have 4 squared, but look right here. This is actually my hypotenuse. These are my legs. So notice now it's not 4 squared plus 8.5 squared. 4 squared plus x squared equals 8.5 squared. So it's 16 plus x squared equals 72.25. I'm going to subtract 72.25 minus 16. Get x squared equals 56.25. Take the square root of that, so that means my leg right here. 7.5. 7.5. Alright, so these problems here, you have to think a little bit. Problem on the left, they give me that from here to here is 1.5, that from here to here is 1. That means my entire length from here to here is 2.5. Now you're sitting there saying, well, how can I do anything? Well, notice this, guys. This is what we call a radius. Do you see another radius in the problem? Yes, right here. So if the one of the blue lines is 1.5, that means the other blue line is 1.5. We have a right angle. So now we have our triangle. 1.5 squared plus x squared, because that's a leg, equals 2.5 squared. So knowing a little bit about radius, we were able to figure that out. 1.5 squared is 2.25 squared. And that's 6.25. If I subtract that from 2.25, it's going to be just a 4. My answer is 2. Over here, you're saying, oh, I have a right angle here, but 6 is only from here to here. It's not the whole thing. That's radius. This is radius. That means the entire diameter is 12. So I take 12 squared. Plus now I'm allowed to take 6.4 squared because that's a leg. That's a leg. And that's the hypotenuse. You know it's hypotenuse 90. Bam. So if I take 12 squared plus 6.5 squared in my calculator, I'm going to get 184.96 equals x squared. All I have to do is square root it. You get x equals 13.6. That's the answer. Alright, the question says determine if the segment is tangent to the circle. Now, the theorem says if it's tangent and it connects to the radius, then it's a right angle, which means it's a right triangle. So, if this is a right angle, then it's tangent. If this is a right triangle, then it's tangent. If right triangle, then it's tangent. So the question is, how do we prove that this is a right triangle? Well, we've done that before in the past. We just plug the numbers in the Pythagorean theorem. Look here, I have a 16, which is this side length. From here to here, it should be 20, and I got 20 because I took 8 plus 12. Now the question is, what's this side length here? Well, you should notice that this is a radius, and so is this one right here. So 12 is the radius here, that means this is 12 right there. So notice that this will be the leg, A, this will be the leg, B, this is the hypotenuse, C. So let's plug everything in. And we'll put 20 squared. So let's take 12 squared plus 16 squared, not calculated. 12 squared plus 16 squared, and we get 400. If I take 20 squared on my calculator, I also get 400. So let's get a check mark. That means it is tangent. And we know it's tangent, guys, because that triangle that's created is a right triangle. So that means it's a right angle. So that means it is tangent. That's how we know. Alright, so we're determining the segment. So we're just typing this number into the Pythagorean theorem. And then figuring out if they're equal. That's 13 squared. Bad looking 13. So 6.6 squared plus 11 squared. This all comes to 164.56. So it's got to come out to be exactly the same, which I don't think it will. It comes to 169. So it's not. So it's not tangent. It's not that it's not a right angle. That's correct. But the question is asking if it's tangent or not. And it's not tangent because they're not the same. Alright, once again, determine if the segment is tangent. Segment's the one that's 12. So we need to plug it into the quadratic formula. 12 squared plus 16 squared and 20 squared. Oh, whatever. 12 plus 16 squared, 400. And 20 squared is also 400, so good tangent. There you go. Alright, this is the last one with tangents. This is determined if it's tangent, so 11.4 plus 15.2. All these should be squared. Squared equals 19. So, okay, remember the reason we know that is first off, you should know that the hypotenuse is always the biggest one, so 19 is the biggest one. So 11.4 squared plus 15.2 squared. So if I multiply it, I can get 361 equals 19 squared. It is exactly 361. So that means it is tangent. Remember, when it says if it ever says explain, this is your work to explain right there. You don't have to answer anything else.